Hi everyone, my name is Rico. I'm a machine learning engineer at Sainsbury's, and today I'll be talking about how we're at Sainsbury's how we are bridging the gap between model creation and deployment. And the kind of like tagline is how we productionize data models to run in the cloud within hours instead of days or even weeks. Um, I'm briefly going to talk about the problem like at hand, and then go into this framework that I'm using as a demonstration, which is Metaflow. It was developed at Netflix, and I will explain why you would want to use Metaflow, why you should care, what Metaflow is, how it works, and then in the end, I'll give a brief demo and then finalize the presentation with what's good about it and what's not good about it. All right, let's go right into it. So, oops. So no machine learning model is valuable unless it's deployed to production. I guess we can all agree on that. A recommender system is not valuable if it runs on some local Jupyter notebook. It's only valuable once it runs in production on the website and actually produces results for our users. So how do we usually, how does the usual data science model creation process goes at hand? I'm going to use a quite popular framework, the CRISP, cross-industry standard process for data mining, I believe, to illustrate this. So usually we would start with the business understanding. We then have to go into the data understanding. What kind of data do we have here? Data preparation, feature transformation, modeling. So essentially selecting which kind of model is best for the task at hand. And then critical also the evaluation metrics. So which evaluation metrics do we want to use to evaluate whether this model actually performs well on the data. So then there's a 6 step. So these 5 steps are usually mostly owned by the data science team. There's a 6th step involved, at which point usually the data science team would throw the code over a wall, illustratively, to an engineering team, an ML engineering team, who then deploys the code into production. Well, that happens because sometimes we might want to engineer the code in a more reliable way using engineering principles. We might have to make it faster. We might have to code it so it's more efficient. Or maybe so it's just up to, I guess, better engineering design principles. But essentially, we don't want that wall because that essentially creates some friction between the data science and the engineering team, where if the data scientist wants to update the model, update the code, because of some changes in the business logic or anything else, the engineering team has to re-engineer the model for every update, and that's not something we want. So what we want is the data science team to actually own most of this process, even up to deployment. So how can we achieve this with Metaflow? Metaflow's kind of like one sentence introduction is that successful data science projects are delivered by data scientists who can build, improve, and operate end-to-end workflows independently, focusing more on data science, less on engineering. And that's really the punchline here, focusing more on data science, less on engineering. So I'm going to explain how that looks like in practice. With Metaflow, or in general, I mean, when we look at a data science project, there are certain layers involved in the data science model creation stack: model development, feature engineering, model operations, the model versioning, the architecture, the job scheduler, compute resources, and data warehouse. So if we look at that, we can quickly see that the top layers of the stack is something the data scientist cares very much about: the model development, feature engineering foremost. The further we go down the stack, the data scientist cares less and less about, for example, what kind of compute resources do we need? Where do we get the data from? What's that data warehouse architecture? They don't really care about that. As long as it works, well, that's perfect. But at that point, we need more and more infrastructure. So what we want is the data scientist to be able to focus on the top layers of the stack and not have to worry about the bottom layer, because that makes them less productive in what they're actually good at. So Metaflow helps us with that, essentially by automating that lower stack, the lower layers of the stack. So what is Metaflow? Essentially, it's very straightforward. It's just a wrapper for your workflows, and it runs steps as a directed acyclic graph. Amazing word. So DAG. For those of you who are familiar with Airflow or graph theory in general, a DAG simply means that we have a direction, a graph that goes in one direction. So it's like one step after another. It's a succession of steps. And acyclic means that we're not allowed to go back. We're not allowed to go back from step 4 to step 1. There's no cycles allowed. one direction and one direction only from 1 to 4, and then it's done. And yeah, you can model with your favorite tools. You can use all the libraries. You can build with Metaflow, design your workflows, run them at scale in the cloud and in production. You can, there's an AWS backend, which I'll demo in a bit. Essentially, yeah, Netflix is quite integrated with AWS, but it's open source, so you probably can design your own Google Cloud Azure infrastructure as a backend if you would wish. And then, yeah, it was developed at Netflix, and well, Netflix is arguably one of the best ML ops teams in the world, so you can really just like yeah, use their existing knowledge in this space, which is great. So if we look at a typical data science workflow, I'm going to go and explain this example real quick, and then we'll jump right to the demo. A data science workflow could look like this. We have a Jupyter notebook. We have a couple cells. This is dummy code, of course, but I mean, essentially, we would load the data in the first step. We would want to clean the data. We would want to do certain transformations. And then we would want to apply our model to the data to get the results of it. And then we want to do something with the results. We might want to just write them back to S3 for now. This is essentially like a data science workflow. And there's certain steps involved that we would execute in a notebook in our experiments. So if we would visualize this as a DAG, it would look like this. We have the starting step, the transform data step, the apply model step, and then the end step. This is the succession of steps, how we would execute our flow. In Metaflow, it would look like this. So there's very little, it's a very actually super easy transition from a notebook cell to Metaflow. All we have to do is we add this class, which inherits from Metaflow flowsback class. And then we have to annotate our functions that we want to transform into a step with the step decorator, the add step. So as you can see, everything that we decorate with the add step decorator turns into a node in our graph. And to define the transitions in our graph, we have to call self.next. Essentially, this tells Metaflow that after the starting step, we want to run the transform step. After that, we want to run the apply model step. And yeah. And then what we also have is, yeah, I mean, the whole thing now is a graph. So now you might wonder, if this is a graph, why is Metaflow talking about flows? Well, if you think like you might have a configuration file which includes certain configuration for the graph, and this configuration is not directly part of the graph. It would be an input to the graph. So the whole construction you can call a flow. And that's it, pretty much. So that's the flow in Metaflow, a workflow. And if you would execute this, Metaflow calls it a run of your flow. And so what I just showed you was the linear structure. There's two other structures which allow for a lot more flexibility. So one of them would be the branch. So it's essentially a parallel state. So you can run two steps parallel to each other at the same time. You might want to do this if you have, for example, you have a linear regression and you want to try out two different parameter combinations. So this way you could run model A with certain parameters and model B with other parameters, and then check which one is more accurate on your data set, and then just only deploy that one to production. If you want to apply a lot of parameter combinations, you could use the for each structure, which is essentially, for those of you who are familiar with AWS Step Functions, it's just a map state. In Python terminology, you can imagine like almost like a for loop. It would iterate over a list of inputs and apply the same step for all of them. Right into the demo then. So if we were to run this locally now, I'm going to use a very similar graph to the one I just showed you with those 4 steps. And we have one of those at Sainsbury's, which is quite similar. And yeah, so the way we would run this locally is we would just simply call the Python file with Python and then call the file. And then we say run afterwards. We also specify conda as an environment. But yeah, pretty straightforward. And then you can see the RE flow, one flow we have at Sainsbury's. So essentially we have those 4 steps: start, get data, applying criteria, which is where it applies the algorithm, the model, and then the end step. And yeah, so this is, I mean, so what, right? There's nothing really exciting happened here. We just ran the flow locally. It's not really anything we gained from that. Would have probably been simpler to just like run it in a notebook. But essentially, now that we have this flow, there's two really exciting things that come out of this. And the first one is we can run this in the cloud with almost no friction. So instead of having to look at what kind of infrastructure, what kind of AWS service, or how we would like deploy this to the cloud, with Metaflow, it will be a one-time setup of all of the AWS backend. And then all you have to do to run this on an EC2 instance, for example, which is essentially Metaflow uses AWS Batch to orchestrate certain EC2 instances. So that's why you would call with Batch. But AWS Batch is essentially just a high-level abstraction from ECS, so Amazon's container technology, which is some version of like high-level version of Kubernetes. You can think about it like that. So all we would do is we would run with Batch, and now our whole flow would run in the cloud, just like that. It's a one-time setup, and then all the flows you could run just with this annotation. You can also decide if you only want to run, let's say, one of the steps in the cloud. You can also do that, which is really exciting because if for example, if your workflow takes a lot of memory or a lot of compute resources because it crunches a lot of data, you could just run it in the cloud. You don't have to, and while still initializing it locally. So that's already pretty cool. That would also give you the opportunity to essentially simulate how it would run later in production. And so yeah, if we go into the AWS Batch dashboard, we can see it executed the same 4 steps: the starting step, the get data step, the applying criteria step, and the end step. Cool. So now to the one, how do we run this in production? And of course, there's a couple more steps involved in actually productionizing this code. But if we just look at the code, how do we get the code from local to, let's say, AWS Step Functions, which is one way to also execute those workflows as graphs in the cloud. And with Metaflow, this is literally one line of code. You would just transform your local flow. Metaflow transforms into an AWS Step Function, which you can then, you don't need to initialize it locally anymore. You can initialize it through a scheduler. Might be event driven, might be time driven. So every Monday at 2 a.m., for example, we run one of our Sainsbury's flows. And it would look like this, where you just have your step function, you would start the execution, or like I said, you would use a scheduler to do that. And then it would run the same 4 steps just as an AWS step function. Just getting it set up. And then there we go. And I'm going to stop pause right here. So you can see, again, the 4 same steps: the starting step, the get RE data step, the applying criteria step, and the end step, which is now all in the cloud in an architecture that can be productionized just like that. Cool. So that's great. So what is great about this tool? As I mentioned, it's an incredibly fast and easy way from local to the cloud to eventually a production environment, which could be AWS. It's an open source tool maintained by arguably one of the best MLOps teams in the world, which is Netflix. So you're really like standing on the shoulder of giants here. It really empowers, as I mentioned in the beginning, it really empowers the data scientists to own most of the process, even of this deployment, rather than throwing the code over the wall and then when looking at it again, it's completely re-engineered by an engineer or an ML engineer. It's highly vertically scalable because essentially AWS Batch uses EC2 instances under its hood. So therefore, the maximum power you can get is the biggest EC2 instance, which is pretty big. And it's available in Python and R. And you, as I mentioned, you have the ability to run your code in production using step functions, which with simply one line of code that transforms your Metaflow into a step function. Yeah, so what's not great about it? It's a steeper learning curve in the beginning for you data scientists to learn Metaflow, but there's a very good tutorial. There's a couple more talks from the Netflix team, so they make it really easy. They put a lot of focus on the human side of this framework, so it's really easy to, pick up. It doesn't support Windows, but yeah. Windows 10 also has a subsystem for Linux now, so maybe this would mitigate this. I can't speak for that though. And one of the features, but also one of the downsides of it is only vertically scalable. So the maximum is the biggest EC2 instance, which is great, but it doesn't, for example, allow for native support of something like MapReduce. So if you have a job that would require something like Spark, you would still need to call EMR from within a Metaflow step. It doesn't really do that, unfortunately. Right, so for those of you who want to get the hands dirty immediately, there's a just pip install Metaflow and you can get started. I highly recommend the Netflix tutorials on the Metaflow website. There's a couple more presentations you can check out on their YouTube channel as well. And it's definitely worth reaching out to the team because you can essentially get on the Slack channel with them, enterprise Slack channel, where they would provide additional support if there's anything wrong with it. And yeah, this is something we're rolling out within Sainsbury's right now to essentially bridge the gap between model creation and deploying them to production. Thank you very much.